part of BAA's plans for upgrading London's second international airport located at Gatwick, it was decided to construct a passenger bridge to carry passengers from the terminal directly to the aircraft loading pier, without having to brave the UK's winter weather. This being only the second time that a taxiway has been bridged, the first being the Denver, Colorado airport in the USA, and to minimise the disruption to the UK's second busiest airport, the 247-metre long by 30-metre wide by 15-metre high air bridge at 2,880 tonnes weighed more than 6 jumbo jets and was designed to enable its construction and assembly to be carried out away from the airport and then be transported and lifted into position during night periods when the aircraft taxiways could be closed.
This is probably one of the most exciting things BAA has ever done. As an engineer, I know what a fantastic feat it is. We've built and we've moved 2,800 tonnes of bridge, and we've put it in place first time. But most important, of course, are the customers. And what this means is that 3.5 million passengers will be able to benefit from this project. No longer will they have to brave the elements. They can go straight from the terminal building, over the bridge and onto the pier, and then directly onto the aircraft. This has moved Gatwick forward a very long way.
The contract for the construction of the air bridge was awarded to Watson Steel, an experienced company who already had been awarded a number of major projects by BAA. The new air bridge would be assembled at ground level on a construction area about 1 kilometre from its final location, and would then require transporting and erecting in its final position during a 10-day period. However, it was important that the runways and taxiways at Gatwick were able to continue with their normal flight arrivals and departures, and that the stringent safety requirements of both Watson's and its client BAA be met. For these reasons, Watson Steel subcontracted the transport and lifting portion of the project to Fagioli PSC, the international transport and erection specialist, who already had previous experience of working on projects at London's Heathrow airports with both Watson's and BAA. Due to the problems that could arise during the transport and erection operations, it was necessary for the Fagioli PSC project team to satisfy both its client and ultimately BAA that it had the required health and safety and QA/QC qualifications and practices in place to perform such a complex project. As apart from the normal health and safety considerations involved in heavy lift operations, this project was special due to the operation being performed in one of the busiest airports in the world, at a period of heightened airport security due to recent worldwide terrorist activity. Fagioli PSC endeavour to provide their customers with products and services which are fit for their intended purpose, comply with customer-specified requirements, and conform to the company's quality specifications. To achieve this objective, we have established a quality system in compliance with the requirements of BSEN ISO 9001-2000 and health and safety procedures in compliance with the British Safety Council 5-star award. The initial phase of the contract involved the mobilisation and assembly of the Fagioli PSC lifting system to the construction site. The lift system was assembled over a 2-week period, and a test lift of 3,275 tonnes was performed to ensure that all equipment was performing correctly. The lifting system comprised of standard Fagioli PSC tower lift masts and strand jacks, which were arranged at each end of the main span in a special configuration particularly for the project. Due to logistical matters, the client had already installed the tower foundations airside, and we had to utilise these for our system. In addition, due to the sterilisation of the area airside, no stability guys were permitted. It was therefore necessary to fabricate special tower tops and bases for this project to adapt to the Fagioli standard system. The configuration adopted for this operation was as follows: 4 twin base frames, 8 28-metre high rectangular, 3 metre by 2 metre format towers inclined together to form A-frames, 4 twin-top frames incorporating jack support beam, opposing pairs of towers framed together to portalise the whole arrangement to allow it to freestand without guy wires, 8 L450 lifting jacks, each configured to lift a maximum of 410 tonnes. Full remote control of this equipment from a station at ground level. 4 twin anchor housings connected to trunnions on the ends of the lifting beams. Lifting beams, provided by the client, were used as both construction supports and load spreaders during the transportation. Due to the limited time available to perform the transport and lifting operations, it was necessary to transport both the longest section of the air bridge at 167 metres and the gantry system together. This meant a total payload of 2,885 tonnes, which required a total of 120 axle lines of Fagioli PSC self-propelled modular transporters, SPMTs for short, which together made a total convoy weight of 3,407 tonnes. The transport arrangement used to move the bridge together with the lifting towers to the final location comprised of 2 sets of 60 axle lines of SPMTs, 1 set at each end of the bridge, at 127 metre centres, were connected to the tower systems which were supporting the bridge. The key to the success of the transport element of the operation was that both sets of 60 axle transporters would act and steer as one autonomous unit, controlled by a single operator. Special checks were performed by the SPMT manufacturers, Schuler, to ensure that the computer-controlled electronic signalling system would be efficient over 127-metre distance. The final positioning of the bridge was required to be within plus-minus 25 millimetres at each end, and required a 90-degree turn and with very little clearance at each end to fit between the terminal connection piers. Detailed route surveys were performed to overlay the kinematic envelope of the bridge with any airside obstructions, buildings, curbs, traffic lights, etc. Any minor discrepancies in steering between the 2 transporter groups could possibly create enormous torsional forces over the 127-metre distance. And so, a tubular restraint system was designed and installed between each trailer group and the bridge to eliminate any risk. Although the operation was scheduled for a nighttime move, the airport was still operational, and any breakdown, especially at a crucial taxiway, was still potentially disastrous to airport operations, and every conceivable risk or breakdown was analysed and emergency contingencies put in place. The actual movement operations began on Sunday evening, the 9th of May 2004, when the airport perimeter fence was removed, the taxiway closed, and the convoy started its journey. Following the 1-kilometre journey from the construction site, it arrived safely at its final resting place in the airport. Upon arrival at the erection site, the SPMTs were lowered to set down the tower system. This was then secured in place by bolting the tower system to the prepared foundations. The SPMTs were then removed by approximately 1100 hours the next morning, for the final lifting of the bridge section to a height of 23 metres. The SPMTs had meanwhile loaded the 2 support pylons, each 22 metres high and weighing 238 tonnes, and delivered them under the raised air bridge on Wednesday the 12th of May. The pylons were positioned under the air bridge, and the final end sections, each 18 metres long weighing 110 tonnes, were finally positioned on the 15th of May, and the tower system lowered the main section into its final location. The tower system was dismantled and removed from site by the 20th of May, allowing the taxiway to open ahead of schedule. The length of the project from tower assembly, test lift, through to site move and demobilisation was approximately 6 weeks. The number of man-hours throughout the project totalled 3,000. This excluded site meetings, design and build of the tower lift components.
This project is a fantastic example of what AMA is really all about, delivering great value solutions to our customers and the travelling airline public. From a development point of view, we can see a really excellent solution that really makes it easier for travellers to enjoy the experience in the airport. From a design point of view, we see some really iconic design, and from a delivery point of view, what a tremendous experience, on cost, on time and on budget, in a really challenging situation with a huge milestone to meet in the bridge lift. I give my congratulations to the teams.